Okay, so now we're gonna start Vivado, and we're gonna start the one that's bundled with LabVIEW FPGA. It takes some time to start. Okay, so now we're gonna create a project. I always put my code in a directory called work. Then I make it work FPGA now, then the name of the project. So for this case, I called it, let's see, LabVIEW FPGA, LabVIEW IP node. Now I'm picking the FPGA part for the PXI E6592, which is a high-speed serial device. So it's a Kintex 7410T is the model of the FPGA. A little bit older, but it's still good. First thing I'm going to do now is I'm going to create a source outside of a block diagram. That means it's just going to be a free-floating VHDL file. I'm going to name the file full adder. Sometimes it takes forever. It doesn't always happen with Vivado. Okay, so I'm not going to define any pins because I'm just going to cut and paste some code. And once you cut and paste code with pins or ports, it updates correctly. This whole file, I'm going to overwrite it with the contents of my own full adder.vhd. You could see the ports. You could see the actual implementation logic for a full adder. That's carry out and sum out, 1 bit each. Then I'm going to run synthesis. By the way, this stuff used to take a lot longer on older computers and with older versions of Vivado. Actually, before Vivado, there's something called ISC, and that was much slower. Things are getting better. So now we open the synthesized design, and then we're going to write the netlist, which is an EDN file. You can even zoom in on the implementation. You can technically see all the logic that's used in the FPGA. It's a very simple design. So you go File, Export, Export Netlist, pick your target directory, disable the Verilog export. You don't really need it. I mean, you can if you want, but there's no point. And this is where our EDN file is. Look how small it is, 9 kilobytes. Now we're going to start LabVIEW. We're going to create a project. We're going to select the PXIe 6592 high-speed serial board. We're going to create one VI. Well, okay, first we have to add the hardware. I'm going to save this one, and I'm going to call it import edn.vi. And create a single cycle timed loop. Add an IP integration node. As you can see, there's an EDN file, but we need a wrapper for the EDN. So I'm going to call the file fulladder underscore wrapper.vhd. I've prepared this file ahead of time as well. So now I'm going to paste it in. As you can see, fulladder wrapper is the interface. It instantiates the component fulladder once and maps the ports. So now in IP integration node, we're going to add the EDN file and the wrapper VHDL file. We're going to set the VHDL file as the top. We're going to make sure simulation behavior is post-synthesis model for both. And then we're going to limit it to the Kintex family, run check syntax. And now here you're going to see it's probably going to make an error. Let's see. Yeah. So, oh no, it didn't make an error. All right, that's good. All right. If you ever get an error, you just run it again. This has to do with the fact that there's like, oh, there is an error. I'm sorry. So you run check syntax again, and now you should see it run the elaboration TCL tickle script. This has to do with the fact that there are two versions of Vivado installed on my machine via LabVIEW. I think I have 2022.3, which I installed independently. So sometimes the tools, they don't work well together. So that's why sometimes just run check syntax again. If generate fails, run generate again. If that fails, close your project, start over, make sure everything matches. Let's see. Generated IP successfully. There are no clocks, no IP enables, nothing to worry about here. It's very simple. The types are all Boolean. There's our IP. So now we're going to create controls and indicators for every signal, port. And then we're going to go to the front panel. But before we run, we're going to move things around a little bit, right? Make it cleaner, prettier. This is somewhere where LabVIEW kind of lacks. It's very painful. Look at this. There we go. This reminds me of VB6. And before we run it, we have to set the FPGA to simulation mode. Now we click run. As you can see, it's a full adder working in simulation mode. If I were to synthesize this and implement it, it would run on actual hardware. But we have the simulation, which is good enough. Thank you for